Welcome to MOOC will be Richard's Econometrics. Um, I taught you how to do OLS in the last class. So this class will be doing how to check for post-estimation tests and how to correct for heteroskedasticity and serial correlation, and also to account for structural breaks in the model. So I will start by uh, presenting the OLS result we have before. Let's say we actually said we have inflation, we have log of stock, we have log of credit to private sector, we have log of government expenditure, we have log of money supply, and we have exchange rates. So we run as equation, least square. We found these results. Number one, we found that the the model suffers from autocorrelation, and we went to check for the residual diagnostics. We went to the serial correlation LM test. We did lags of two. We saw that um, the null hypothesis was rejected, which means there's no serial correlation up to 2 lakhs. So, which means there's serial correlation because we rejected the null, so we have to accept the alternative that which means there is serial correlation up to 2 lakhs. So we went to run for the heteroskedasticity tests, Brush Godfrey. We saw that we also reject the null that it is homoskedastic. So which means we are accepting the alternative, which means it is heteroskedastic. So this means it is actually not good. So I will teach you how to correct for all this. Number one, what you would do, okay, we also went to check for our residual series, and we saw the movement of the residuals. You can see it's actually an issue. It's supposed at least to lie within the zero bounds. That's what it's supposed to look like. So since we've seen all these issues, what we did was first and foremost, we tried to check if there was actually a structural shock in the model. Sorry, if there was a structural break in the model. So click on view and we'll click on we'll click on multiple breakpoints test because we don't really know which particular point the issue is coming from. So when we clicked on it, we found out that there are issues in 2014 month 11, 2018 month 3, and 2023 month 5. So when we saw this, we've actually noted this the repetition where the break date is where the issue lies. So based on that, we have to, it's the same thing with this, but it is now well aligned properly based on the dates. So based on that, we now created uh, a dummy variables to cater for this break. So after doing that, we put that in our model. So now we have to put that in our model. Let's say we have the 2014 the 2014 SI, the 20 the 2018 and the 2023. So these are the dummy variables we created to help to normalize the structural break. So we run it. When we run it, this is the result we got. We actually went ahead to check for uh, the residual. You can still see there's still an issue with the whole residual series. So we can still go and check for the heteroskedasticity because that's the main point. The serial correlation LM test. What do we see? We see that we still have to reject the null hypothesis. So which means this has not been treated. So what we now did, we now included the lag variable of the dependent variable because it is clear now that maybe the lag of inflation has been affecting the model. After doing that, we click on OK, and then we got our results. And we saw that the result is saying exchange rate actually reduces inflation, money supply reduces inflation, government expenditure and stocks. So we are still seeing that credit to private sector and only credit to private sector actually increases inflation. At this point, that has a positive relationship with inflation. So what we now do, we now um check for the residual diagnostics, um, which is check for the serial correlation, and we find that it is properly well situated now. It looks like this, which means that you have to accept the null hypothesis. You cannot because it is more than 0.05, especially the observed R square. That's where we pay attention to. So let's check for the heteroskedasticity, which is one of the major ones we have. We also saw that the observed R square is higher than the 0.05, which means you have to accept the null hypothesis. You don't have to reject the null hypothesis. You accept the null hypothesis that it is homoscedastic. So based on that, this means that this is the best result you can get. But though the issue now is that most of the probability tests for the T statistics, it's actually not significant. But I just wanted to show you how you can be able to correct for these issues. And another method you can use to correct for heteroskedasticity is also changing the. Let me show you changing the. Creating residuals. You have to create residuals from this your series. You make residual series where you create residual series. You name it as weight, and you put it in the model. So this is it. Put it in the model. So you come to estimates. You go to options, and you might click you might also use this hover white, and then uh, click on add weight series. You click on inverse standard deviation and you add weight series. You can either use one of them, either one, or you use it two. Is the way to create it. Wait, okay. You see, this is where you see that most of the variables are now significant. You see, so this is the one with the weight series. You can see it's making more sense. But still, stocks, government expenditure entry actually shows to reduce inflation. And they are all now, most of them are significant at 5%. Even the shocks are significant, except 2023 and stocks. You get it? And inflation, lack of inflation was not significant. So this is it. So you can check for the heteroskedasticity tests. You can see it is you have to accept the null hypothesis, and also you can check for the serial correlation LM test. You can see you have to accept the null hypothesis. So I think with this I've taking you around how to do your analysis and make a good inference, even when you will have the issue of serial correlation or heteroscalar. You can be able to correct it with your OLS. You might change your model to an autoregressive model in order to solve the issue. You can also correct the heteroskedasticity issue by using the using the white tests to correct it, Hopper weights, and also adding weights, the residual weight into the model. It will make the model better. Thank you for listening, and please do well to subscribe to my channel, watch my videos, like and comment, ask questions that you want me to treat, and let's make this channel grow. Thank you for listening.